Hello, I'm Philip Doganis and I am excited to be presenting you Jaqpot, a computational cloud platform supporting the design of safe and sustainable chemicals and materials. This is work by the Unit of Process Control and Informatics from the National Technical University of Athens in Greece. Successfully introducing innovative advanced materials and chemicals requires finding an optimal balance of safety, sustainability, functionality, and cost efficiency, especially when we're working in a safe and sustainable by design framework. The computational approaches here aim at implementing the by design approach by formulating and solving optimization problems that identify combinations of properties of these four categories, thereby enabling targeted materials innovation. This challenge is addressed by Jaqpot, an open source platform designed to facilitate the development, deployment, and management of machine learning models and other computational models specifically tailored for chemicals and materials modeling applications. Jaqpot offers you a model repository where you can access specialized ready models. They are organized by category, they can be publicly available or shared within organizations, and for a private repository, private part of the repository, we can see what we have created for the PINK EU project where we participate. This is a private page for the project, only participants of the project can access it, and of course at any time it could be shared externally. Each model has its own web page with information, the information that was entered by the creator of the model to give people an understanding of what the model does and how it was built. It also provides access to the features, what it needs to get as input, and also what is predicted, here the dependent feature. And one can get predictions either by providing a single molecule, as we see on the bottom right of the corner through its smiles, or by providing a series of molecules through their smiles in a CSV file. Either way, one gets access to the prediction tab after that, where the prediction is provided, and also information on the applicability domain is given. Furthermore, metrics are provided for the models in order to provide the user information on the model performance. In another approach, if someone wants to create their own model and share it, this is possible and very easy in Jaqpot. Starting from data by using only this line of code and providing the name, the desired name, an arbitrary description, and the visibility setting, private or public. You can use Jaqpot-A either directly or first take advantage of the descriptors engine, and you can use Jaqpot-A to use this one line of code to go from data to online model through the architecture shown below. This makes this gives the user a model that is instantly accessible over the API, a model that instantly has its own web page that others can use, and the model that is instantly accessible over Python. Another direction of our activity is using AI agents for SSBD. And here in this example we see how we are working on conversational support for materials design. It is possible to run models using natural language by having AI agents call the API and receive predictions and give us back the answer in natural language that we give. Here we see an example for the solubility of methane. Another direction of our activity is generating new structures with desired properties by harnessing generative AI to generate new structures with desired characteristics. One example here is a generative AI GFlowNet model that generates molecules with high log P values. Um, Here we see an example set of 10 molecules that was generated by the algorithm, and they were tested uh, through um, comparison to QSAR Toolbox, and the comparisons show generally a good agreement. In another application of Jaqpot-A, we used it in the pink assessment report to integrate new um, uh, hosted public and private models, used the derived predictions from the Jaqpot hosted functionality of QSAR Toolbox, which is processed over Jaqpot-A and made accessible over API, programmatically over Jaqpot-A, and use also EPA's CCTE API with direct access to their API. All these sources are used to derive predictions for assessment categories when as much as possible that is available through these sources. And for each assessment category, results from multiple categorical models and profilers are processed to produce a consensus value, which looks something like what we show you here on the right hand side of the slide. And here we show how many models vote positive or negative. Of course, the whoever does the assessment should take a look at the underlying predictions that were used to get these figures in order to make a truly informed and rational assessment. If you want to see how it works and how easy it actually is, you can use the multiple examples that are offered in the main repository, or even for an installation-free way to do this, you can use the Google Colab examples in our repository. They run directly in the browser without any local setup, and it makes it easy for you to check it. To summarize, the key features offered by Jaqpot are a machine learning model repository with specialized cheminformatics features, the Python integration through the Jaqpot-Py library, a support for various machine learning frameworks offered by Jaqpot, domain of applicability features with specific to chemical modeling, its support of fair data and model practices, its advanced pre-processing and featureization capabilities, and the offering of API access for programmatic integration. Jaqpot is available now. We strongly urge you to try it at apt.jaqpot.org. If you need help from the documentation, please feel free to contact us. The documentation website is at jaqpot.org.